Now that I've created an empty shapefile to store the digitized information, I'll perform a coordinate transformation, also known as georeferencing, on the source dataset so that it's in an Earth-based coordinate system. In this case, the target coordinate system will match the parcel shapefile. It'll be in New Mexico State Plain Central. To perform this task, I'll be using a plugin. Plugins are small add-ons to Qgis. Some are created by the core Qgis development team, and others are created by third-party developers. The next step is to turn on the plugin. I'll do this by opening the plugin manager. I'll go to the plugin menu, manage and install plugins. And from here, I can choose to look at all plugins, just those that are installed or not installed, or go to plugin settings. The plugin I'll use is a core Qgis plugin called georeferencer Goodle. Since it's a core plugin, it comes installed by default and I'll just need to enable it. So I'll select Installed Plugins and just check the box next to Georeferencer Goodle and click Close. To open the Georeferencer plugin, I'll go to the raster menu, to Georeferencer, and open the Georeferencer plugin. And from there, I'll add my source dataset by clicking the Open Raster Data button, going to my Data folder, and choosing the Zone Map dataset. This dataset does not yet have an Earth-based coordinate system. It has coordinates generated by a digital scanner. On the map, there are parcel boundaries and 5 points. The parcel boundaries are labeled with their zoning code, and I'll be entering those into the field I just created in the last task. There are also 5 points. These are the benchmarks maintained by the National Geodetic Survey. To georeference this scanned map, I'll create control points at these 5 locations. The plugin will develop a georeferencing equation based off the set of source and target coordinates at these 5 locations. Qgis will obtain the source coordinates from my mouse clicks on these points, and I've already looked up the target coordinates for these benchmarks from the NGS website. The next step is to enter the control points in the georeferencer with the Add Point button. I'll click on point I-2527. When doing this, it's important to be precise and click directly on the point. The accuracy of my transformation depends on precisely locating the points. If I want to redo a control point, I can use the Delete button and click on that point, remove it, and re-add it. So again, I'll be clicking on point I-2527, and the Enter Map Coordinates button comes in. Now I've already recorded these coordinates, so I'm just going to copy and paste. Here's the X coordinate. And the Y coordinate. Now that I've done that, I'll click OK, and I'll see the red control point enter on the map. I'll repeat this procedure for the 4 remaining benchmarks. Now that all 5 control points have been entered, I'll click the Start Georeferencing button to begin the process of georeferencing the image. If you see this message, please set transformation type, just click OK. We'll be doing that in the transformation settings window here. We'll choose a transformation type of polynomial 1 and a resampling method of nearest neighbor, so we'll take the defaults there. And we'll be choosing the name of our output raster. So we will go into the new data folder for our lab and just take the default name Zone Map Modified and click Save. The target SRS we want to be EPSG 2903. If it's not picked by default, you'll go into the CRS selector, choose that EPSG code. It should be in your recently used coordinate systems at this point, and click OK. We want to make sure that Load in Qgis when done is checked, and then finally we can click OK. The transformation is done. We can close our georeferencer window and click Save to save the points. Since my map started with only an empty shapefile, I'll need to right-click on my new Zone Map Modified raster and choose Zoom to Layer Extent to see it. As a final test of the process, I'll click the Add Vector Data button and go to my lab data folder and choose netcur.shape. Let me give this a darker background so that you can see it a little better. This is the shapefile representing city streets produced by the city of Albuquerque. If the transformation was done correctly, the streets will line up with the georeferenced parcel image as you see it does. In the next task, you'll learn how to digitize the parcels off this georeferenced scanned map into your polygon parcel shapefile.